Okay, welcome back everybody to my programming in ARM assembly video series that I'm putting together. Let's jump back into our code. So unfortunately at the end of video 9 I forgot to make a backup of the files, but I remembered to do it at the end of the last video, so I'll have potentially one video there that I don't have a record of, but that's fine. Okay, so at the end of the last video we have our random number generator constrained to the point where it's guaranteed to not exceed the value that we're passing in as max rand. So I think at this point I kind of want to just go through, do a bit of code cleanup, get rid of some stuff that we don't need anymore, comments that we don't need anymore, that kind of thing. And let me just check here, so we don't need this stuff anymore. That's fine. Got our messages there, that's all fine. So the code, the main code is looking pretty clean. So I think we're okay there. Let's write that out. Let's quit. Let's check random, because I feel like there was a bit of a mess still maybe in there. Maybe not. But I think it's possible that the number could potentially be 0. And so I think what I want to do, now that at this point, the number is guaranteed to be less than or equal to max rand. So how do we want to decide? How do we want to handle if it becomes 0? Because I don't just want to say make it 1 necessarily, or make it equal to min. I mean, I guess we could like generate another random value maybe and do something with that. One thing we could do actually, if it's equal to 0, we could just have it redo everything. So that's a possibility. Like if the number is equal to 0, just go back to the top and start over. For now, let's be a tad bit lazy. Yeah, for now, let's be a tad bit lazy. Say final min rand check, and we'll say compare R0 with R3, which is the min rand. And if it's less than that, think about this for a second. Basically, if it's less than that, just make it 0, or make it equal to max rand is what I want to say. So compare R0 to R3 and branch if less than to fix min. Otherwise, we're done, so we'll branch to the exit. Actually, I think there's a better way to do this. I think there's like comp s, CMP-s. I'll have to look into that. Let me actually look that up really quick. ARM assembly CMP-s. Because I think I can set the flag immediately without having to jump anywhere. What's this? It's not even okay. Let me look into that a little bit. For now, we'll go ahead and do it this way. We'll say compare R0 to R3 and branch if it's less than, and the place that it'll branch to is right here, which is going to be fix min, and then so if it's If it's less than, then we'll say that R0 is equal to R3. We'll just copy the value of R3 into R0 so if for some reason we end up with a number that's lower than the minimum, we'll just set the value equal to the minimum. Currently that wouldn't be possible because our minimum is 1. Or I should say if our minimum 0, but let's say we change the constraints to like 25 to 75, and actually that would be a good test. Let's actually do that. Let's quit out of here, let's remake. Oh, wait, let's change the constraints first. So let's say that the minimum number is 25 and the maximum number is 75. Remake our code and play our game. So the number should be guaranteed to be higher, 25 or higher, and it's not. That's 24, so we got an issue here. I might be doing that comparison backwards. I seem to get that wrong all the time. So let me come here and compare this in the other direction. So the number should be guaranteed to be 25 or higher, and it should be guaranteed to be 75 or lower. Okay. So that constraint is valid. So let's set up another constraint. I'm not even sure if negative numbers will work here, but let's try it. So let's say like that, negative 25 to 0, but I'm not sure if I can even type in, I don't think I can even type in negative numbers the way I'm doing my checking. So I don't think that'll work. I don't think I can type negative numbers in. Think about this. Yeah, I'm not going to worry about negative numbers for now. I'm going to worry more about it for a general purpose. We would want to worry about negative numbers, but for now, let's not make it that hard on ourselves. So let's try a minimum number of 1,000 and a maximum number of let's say 1,100. So it's still 1 to 100 type of thing, basically. Let's remake our code. Let's play. So it should be guaranteed to be higher than 1,000, or 999, I should say, and it's not. So it's between 6 and 8. That's weird. Think about this. We were doing so good. So we're setting R0 equal to minimum. Let me try some more ranges. Let's try 500 to 600. Clear, make, run our code. So it should be 499 or higher, and it's not. I must be doing something wrong with my bit mask. Yeah, I'll have to think about that. Because it seems like it's always close to the range, but like below it. Let me try 300 to 400. Remake, run. So it should be 299 or higher, and it's below that. So it's below. So it's below a 5-bit mask. Next would be 63. So it's between 63 and 127. So it's between like a 5, or I should say, it's between a 6-bit bit mask and a 7-bit bit mask. Let me try 100 to 200. So it should be 99 or higher. Yeah, it seems like it's always... Let me check something here. Maybe I am checking something wrong again. Probably here. Let me get rid of this for a second. And let's check main again. I think maybe that minimum thing I'm doing is messing everything up. I probably set that minimum to check in the wrong direction again, so I probably have everything right. And then when I'm checking the minimum, it's checking it backwards, so it's setting the value in the other direction. That's my guess. So let's try 100 to 500. Although it could be below 100 because my minimum currently isn't being checked. But let's make sure it's not over top of the top end. So that's too high. That's too high. Okay, so it's the high end is working. And let's say 10,000 or something potentially. Make, run. So too high. So it's over 1,000. Okay, I think I can worry about the random. I can worry about making the random thing better for another program where that might actually be desired. So I think I'm actually just going to call it a win and be done at this point. Let me just check one more thing on the random. So I think I'm probably doing this backwards, even though I changed it once already. Compare the random number to R3, and then if so R3 is minrand, and I'm not overwriting that anywhere, am I? No. So the only place that minrand exists is here, here, and here. Branch if less than, fix min. I think that's right. So let me check the main again. Okay, remake, run, oops. In random, I think I uncommented a comment. Yeah, that's exactly what I did. Okay, so 0, 1, 101. Okay. Okay, rerun it. Okay, I feel like this is working, and let me just do one more check. Let's set the minimum number at 10, and we'll leave the max where it's at. So 10, too low, 100, too high. Actually, I think it'd be better if I really narrow the range down to something like that. So I could see often, well, okay, so that's too high. So it's not limiting it correctly. Oh. So now all right, let's see if we can figure at least a little bit of this out. So I set the minimum number at 80, and somehow it came out as 3. So let me actually really limit the number between 95 and 100. And let's remake our code. And let's look at this in the debugger. Break 1, run, step, oh, okay, yeah, that's right. Step into, and let's see what's going on when we get into that last part where we're limiting the lower number. So we create our bit mask. I already know that's working because I already saw it. Okay, we're getting ready to come out of that loop. All right, step here. Now compare R0 and R4. R0 is 1F. R4, I don't know what those numbers are. Let's check. R0 is 1F. It's 31. R4, well, R4 should be... Oh wait, currently we're comparing the max. I want to compare the min. So step. And the number was 31. Okay. I think I just see what happened. Continue through to the end. X quit. I am not checking here. Yeah, I need to... Yeah, I'm jumping straight to the exit. Oops. Yeah, when I do this final check, if the number is less than the max, I'm jumping all the way to the exit without actually checking if it's less than min. So we need to do a min check jump. There's a better way to do these. I'll look into that later. Okay. So we currently have our range to 95 to 100, so let's check. 90, too low. 94 should be too low. And then 100, too high. Okay, so yeah, it's got to be in that range. And I could see this being a problem where, because it's so limited in the way we're doing the minimum checking, we're forcing it to be the minimum number. So, and since we've got this massive pool of numbers to choose from, and we're limiting it to 5, and anytime it's below that limit, we're just hard coding it to set to the minimum. So that's not very good. But normally I don't think that'll be a problem, because normally we're not going to limit it so much. But let's check to make sure that, like in this case, 1 to 100, let's make sure we're not constantly making it 1. Okay, and then 101 is too high, 0 is too low. And then, okay, so, all right, so I'm going to mess around with this a little bit more, but I think for the sake of this video series, I've pretty much accomplished everything I wanted to accomplish. So I don't think there will be any more parts to this series. Possibly, never say never. But I think as far as the number guessing game portion of it goes, I think it's done. So let me just go ahead and, all right, I've already changed that back. So the only thing that I might do before I completely upload like a final version of this is just go through and do any little bit of cleanup, stuff like that. If I do any like major changes, I'll make another part. But otherwise, that's going to be the end of the video series. I hope you enjoyed watching, and I do plan on doing some more programming in ARM assembly, because I have some other programs in mind that I'd like to mess with. But yeah, that's going to be it for the series. Thank you so much for watching.